Welcome back, everyone, to Merge Conflict, your weekly developer podcast where we're diving deep into world of augmented mixed virtual reality-esque stuff with visionOS. Yes, visionOS has been out for us to start developing for the last several weeks, and we had a podcast on it where we talked a little bit about exploring the spaces and what you need to know. And Frank has been diving deeper into the world of 3D objects for visionOS. If you're brand new to the podcast, I'm James Montemagno, and yes, that is Frank Kruger on the other side of the microphone. How's it going, buddy?
Hello, sir. I can't believe we're going to do another Vision Pro. This is my opportunity to say again, I still haven't decided whether I'm ever going to buy one of these things, but gosh darn it, if I'm not going to play with the SDK and play hard and see what I can do with the thing and see what crazy new APIs they're adding.
Well, I've always been a fan of attempting myself to build 3D things. You know, like I said, I started my career in video game programming and doing 3D things, you know, on a 2D surface, but not necessarily in the mixed reality, virtual reality, augmented reality space. And for me, you know, I think that the space has always been very intriguing to me because the very first time I got my Nintendo 3DS, a few cool things happened. One, it was like 3-dimensional coming out of the screen, which was really neat, like mind blowing. But they also had the ability to do augmented reality. They had these really cool cards that you could put down, and they were like little question marks, and you'd put them down and 3D figures would pop out of them, right? But you're seeing them also in 3D and they're doing stuff because all this cool stuff. So to me, there's a lot of coolness that goes into that. But I am not a graphics designer. I'm not a 3D modeler. I took a Maya class or whatever in college, so I made a teapot. But beyond that, I really don't know what I'm doing. And so the thought of moving into the 3D space is very scary for me, right? Because I understand the 2D level system, right? I've been building desktop apps, web apps, mobile apps, tablet apps, TV apps, whatever, for a long time. And I feel comfortable in a 2D, that Z-axis, I got away from it after game development. I got like Z-axis, get out of here. Boom. I like to live in a 2D world, Frank Kruger, but they're forcing us to move into this 3D world that's also kind of 2D, but also 3D.
Oh, it's 3D. It's 3D. We're just helping the 2D world, pulling the 2D world into the 3D world. That's what we're doing. And yeah, you hit the nail on the head there. I love 3D. It's what got me into programming. It's what I love to do with it. But at the same time, I'm not a good 3D artist. I know how to use every CAD program a little bit. I can get usually a square. Usually I can get put a hole in the square if I'm feeling lucky. I write CAD software, and yet I'm still not a good artist. The designs I come up with are functional. They're simple, and they work, and they're basic shapes and all that kind of stuff, and I love it. It's fine. I am not an artist. And so, my goodness, like I would almost say my whole career has been me finding ways to have computers generate art for me. I'm really into neural networks. We talk about them all the time. And the neural networks I'm really into are the generative ones, like so your DALL-Es and things, but I like to run those in 3D also, making 3D shapes. But yeah, we're in this world of augmented reality where you want to bring 3D shapes and augment the person's 3D world with new 3D shapes. And you got to get them from somewhere, James. And you're not an artist. I'm not an artist. Yeah, even the Fiverr artists are usually more like $50 artists at minimum. What is one to do?
That's a good question because we've talked before on the podcast about iCircuit 3D, which is one of the applications you make, which is 3D, which is the app that I'm pretty sure should be on the Vision Pro. We talked about your 3D holograms, and we've also talked about you scanning a shoe and turning that into a 3D object as well. We've talked about multiple 3D things. That's probably just some in the 585 episodes that we've done at this point of building 3D applications in general. So I don't know if any of those mechanisms are going to work. But what did you do for iCircuit 3D? Are those things that were generated out of primitives, basically, or no?
Okay, so I'm gonna toot my own horn a little bit. Please excuse me here, sir. That's the best artistic CAD modeling I've ever done. Each one of those parts is myself generating.
Wow.
In a various assortment of ways. I wrote sub-programs and programming languages so I could write the shapes of the parts, and it was complicated, probably a little overly complicated. But, I wanted my resistors to look a very specific way, and I wanted them to be resizable dynamically, so the shape generator had to be a dynamic shape generator. And that is a way to do it, everyone. You can just write code to generate 3D shapes. It takes a lot of math. You gotta type a lot of numbers in and recompile a million times and see how those numbers affect things. But that's one way. I don't recommend it. Side tangent. In the 3D printer world, people are actually starting to use programming languages to generate CAD files. So one popular one is called SCAD, S as in the letter. OpenSCAD is a whole programming language devoted to generating 3D objects, 3D solid objects. Super cool. There's another one that's a little more tame, which is JSCAD, OpenJSCAD. It's a JavaScript one. You write JavaScript to create 3D objects. Back in the day, I wrote one of these for C#. You could write C# code to generate 3D objects. So there is a place for that, but it's tedious, and your designs usually come out simple because you're writing literally every bit of that object in code.
Yeah, that makes a lot of sense. Well, and like you said, you also need to know math, right? I think when we were building the game engine out, it's a lot of math, it's a lot of computation. It's there. I mean, luckily at that time we were at least running DirectX. So if you get things into a .x model format, and then things would magically work. But the designers, that was their part, right? We dropped it in. I was more on the rotation of the ship when things got hit, the shield, the bullets, the shaders of the different atmospheric things that were happening on in space, and then just sheer collision, right? I mean, there's 2D collision, not like a 3D collision. You want to make sure your ships aren't just floating off to the ether into the ether magically or whatever, and then making sure when things happen accordingly. Just like I keep hitting my microphone for some reason on this podcast, but yeah, I think that's the problem I've always had, is that it seems like it all takes a lot of time, right? I'm not an artist, so it really scares me in general. But do I have to do that for the Vision Pro, visionOS? Like, that's an option, I assume, right? You should just be able to take everything you did for iCircuit 3D, and like that should work for 3D modeling inside the Vision Pro. Do they have backs? Do they have undersides? You can rotate them? Because like in video games, often it's not even the full thing, right? Like often, if it's a house, they just control the camera, right? So literally, that's why the funny things is like when you go through a wall accidentally, there's nothing on the other side because they're not going to render the whole geometry. It's literally like half a house, so that's why it's always kind of funny.
That's a fun example too, clipping through walls. Clipping works because walls aren't actually solid. Walls are two-dimensional triangles oriented in a three-dimensional space to create the illusion of a wall that's not actually a solid object, so you can clip right on through them. Fun. But no, you know what? I actually want to go back to the shoe that you mentioned, because that is a way to create some geometries and things. And the shoe, if you don't remember episode who knows what, we were talking about Apple built in a sophisticated little algorithm called, well, in general, the concept is called photogrammetry. It's a terrible name. The algorithm is called structure from motion. What it actually does, though, is you take a bunch of pictures of an object and it generates the 3D object itself into a nice little tight format. And James, yes, it has both sides to it, which is actually a very
Mm.
impressive thing. I want to actually talk about that, but we can save that a little bit for later. But that is actually an impressive thing, because if you think about, like, what if you want to scan, let's say, a shoe, and it's just sitting on the floor? You walk around it, you take a bunch of pictures of the shoe, and you're like, generate me a shoe. Well, what in the world is the algorithm supposed to put at the bottom of the shoe? It only has the one side. It doesn't know. So a very sophisticated thing in the Apple algorithm is that it can do both sides of the shoe. You can flip the shoe and scan both sides. So it won't be your cheating gamer thing. It's going to be both sides. And for the record, iCircuit 3D is both sides also, because I didn't cut any corners. Those are full solid 3D objects.
Of course they are. Well, I think the idea here, if we go roll this back even before that, of taking a bunch of photos and turning those into three-dimensional things is not necessarily a new thing. But I think that the technology, and this is what I want to distinguish, because some people might think, well, hey, I've been on Redfin, right? I've seen this, thing where I can like get a 3D tour, right? Or I've seen maybe like Google, for example, like when you go on Google Maps and you tap on a restaurant, you can go inside a restaurant because like enough people have photographed the inside of it, or they've gone in and they've done something. Or,
yeah,
a good example is on my Android phone, there's a way to take a 3D spherical thing, right? But the idea there is like, it's not necessarily 3D, right?
Right.
I don't know what the thing with 3D is like, is texture and depth, right? The depth aspect of is that like, so I'm not sure how those, applications that like, oh, just take a bunch of photos of this room and it'll figure it out. I'm assuming it's mapping walls to figure out like meshing basically, but I don't think it has the depth sensor. And I think that's what sets apart this type of technology, is the depth data information. Is that correct, or is that meaningless in this case?
No, you're right. You're right. I want to take it from a slightly different tact, though. I would say there's when you're talking about 3D and visualizing 3D, there's two things to think about. There is, in what way are we storing the 3D information, and then in what way are we visualizing that storage of the 3D information? And there's different algorithms for the same storage, different ways of storage, and particular algorithms for that. The most common storage, the one that you want in visionOS, is a mesh. Your happy old mesh, your triangle mesh. So just a bunch of triangles that are texture mapped. That is the format. That is the format we've been using for 30 years for games and everything. It's old, but it works. We like it. Triangles, computer graphics cards can render them very quickly. And so a lot of the things that you were talking about, like the Redfin one, that's actually different. They're doing like the trick from Photosynth. Do you remember Microsoft Photosynth? Yeah. They're doing the cool thing of, if you can figure out how a bunch of pictures that you took are positioned and oriented in 3D space, then your representation of the 3D world is just a bunch of pictures oriented and positioned in 3D space. And then you have to write a sophisticated little renderer that figures out which picture are you facing. Don't draw the ones behind you, draw the ones in front of you in depth sorted order. And then you can do a very simple visualization. So does it have depth? That's a philosophical question, because like as you move around, it gives the illusion of depth. What is depth? But everything's an illusion, whatever. It's not giving depth in the way that a 3D mesh has depth, in that there are hard-coded numbers in that 3D mesh file that tell you exactly what the z-axis is, what the x-axis is, and all that. And so the neat thing that photogrammetry gives you is, from a whole bunch of pictures, it's not just a visualizer, it gives you a mesh. It gives you a bunch of triangles. It can give you other things too, point clouds, stuff like that. But really, in this world of trading 3D objects, you want a mesh, it's going to give you a mesh. And that's what's so cool about it.
Now, when you did the shoe, right, that was an app that you had on your Mac, and you had to like photograph it with your Mac's camera. How did you do it back in the day? This is like a year and a half ago, maybe a year ago.
Yeah, a year and a
2
half,
years ago?
2 years ago, maybe even.
Yeah.
So I first did my first experiment when Apple introduced photogrammetry support on Mac only, which was weird. It was still part of RealityKit, and you're like, well, there's nothing stopping that code from running on iOS, but it had to be like some kind of, it's going to burn the battery or it's going to use all the RAM. I don't know what, but it wasn't on iOS. So the way I wrote it was I wrote a Mac app. I think I even wrote it in Swift. I even spent some time on it. I polished it a little too much. And I even started writing a transport between an iOS app. So you go take the pictures with your iOS app, and then it would easy transport it on over to the Mac app, run the algorithm on the Mac app. I never finished it because I hate clunky solutions like that. I hate an app split in two halves and they have to communicate. And I'm like, this is not sparking joy in my heart. As much as I wanted some photogrammetry in my life, it was not sparking joy. I should say, just one little step back. My previous experience with all of this was I downloaded an app for my drone where I could fly my drone around and take a bunch of pictures, and then it would turn it into a 3D mesh like Google Earth style.
That's
so
cool.
It's like a Google Earth Maker, but it was expensive. It was like $100 a month to have access to that algorithm. And so then I looked into open source ones, and the open source one was very complicated to use. That I had trouble. I got it to work once, and then a day later completely forgot how to use it ever again. And then leading up to all this, there's another open source one called Colmap, 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 which is really good. And I even went through the effort of creating a .NET binding for it so I could put it into my app and everything. It just had one problem. It used all the RAM on your computer. So you would ask it to do a task, and it just chewed through all your system resources. All the CPUs at 100%, RAM at 100%, and it's just burning away. And so a real kick I got was I then ran the Apple algorithm, and it finished quicker and used, 1/10 of the resources. So here's to a very large vendor with lots of money optimizing their libraries.
Yeah, that's the best way to do it. Of course, if any of those other ones worked, like fantastic, but, if it's in the box, it's much, much better.
Yeah, and I'm completely blanking on, there's a commercial offering that graphic designers actually use when they're doing like professional photo scanning, and everyone basically uses that package. So it's a little bit Apple coming out with their guns loaded, releasing what I think is a really good algorithm. Can we go back to discussing flipping objects over? Because I think it's super cool.
Yeah, because you said now basically that exact same app and logic, I just want to get it straight, is just now available on iOS 17. Like, hey, they're like, oh, now we'll no longer throw an exception basically at this point. So your Mac app, you could just take that logic and shove it into an iOS app, and then you're good.
Yeah, they actually did two things to help out. They enabled it on iOS. The API didn't even exist before, so it's not even like it threw an exception. It just didn't exist before.
Wow.
Yeah. So that's actually the real reason I wanted to talk about it today, because I'm just so giddy that we can actually do photogrammetry. And you know what? What's really making me annoyed, though, is the documentation says it's supported on visionOS, and yet visionOS Beta 1, I cannot get it to compile. The library is just not there. The header files just aren't there. So, but it's on iOS, it's on Mac Catalyst, it's on Mac, it's been on Mac. So that's the big announcement. That's why I'm so excited and wanted to talk about it today. But I also wanted to talk about it because it's cool what they added. It's very sophisticated and very powerful. And we should talk into some of those bits.
Now, they didn't necessarily release a complementary app onto the App Store that just lets you do it, do they? Because ideally what would be cool is give me an official, image generator thing from Apple that's like, hey, are you building visionOS apps? Download this tool that will help you create 3D models, and it'll be great.
So I want to answer that question in multiple parts.
Okay.
So, because it's complicated. It's complicated, James. No app so far. But like, if it's going to be supported on Vision OS, doesn't it make sense that when you're in an AR environment, you can just be like, I need to scan that object? So I'm hoping that they have some Vision OS app in the works because it's pretty obvious. And I'd be writing that app right now if I could get the stupid thing to work in the SDK because it's so obvious, like it should be there.
Yeah.
So no announcement of an app, just the API. And they've started documenting it a little bit better. Documenting it in a way, James, I think you would appreciate because Apple doesn't write docs. What do they write? Samples.
Yeah, samples. They love samples.
And what they released is the most over-engineered sample you've ever seen in your life. It just has abstractions, additional UI that does this, UI that does that, UI that does all these other things. So they have 3 total examples you can go get that give you a decent feel for how these APIs work and how you can build your own. But I want to talk about their over-engineered one because it's hilarious. It's basically the app they should be releasing. It's essentially an entire app. All it needs is a project navigator, and that's it. Good to go. So what they did, not only did they enable the APIs, but they enabled some user interface stuff. Before, you were kind of left as the developer to go collect a bunch of photos from the user. And that you could pop up a dialogue and say, please select a bunch of photos. But what you really want is they're holding a phone with a camera on it. You really just want to go take some photos. And honestly, it's not rocket science. Like, it's probably 100 lines of code to get a camera preview up on the screen, put a little button on there. Whenever the button clicks, grab the frame somehow, write it down to disk somewhere. But it does have its tedious bits and all that kind of stuff. Well, there's a lot of, yeah. When you're scanning something, here's that pause that's happening in my head. Are you scanning an environment, a scene, or are you scanning an object? So what they've done, their API, the photogrammetry API, supports both. You can go, take pictures of your house and your lawn and all that kind of stuff, and it'll stitch them all together and give you a nice little model of it. But they built a UI that helps the user take photographs of an object, and it's very object focused. So you're not supposed to be walking around your house and taking pictures like that. It's very much like, select the thing in the center of the screen, now walk around it, and it plays like rotation music, like a little dance jig the better you're doing. And if you get too far away, it beeps at you and you're like, oh, I'm sorry.
Oh my gosh.
I'm sorry, little guy. It has animations on it. They have like 4 whole Swift files devoted to just animating this one little icon on the screen.
Oh my gosh.
And it's a weird mixture of the OS provides you 50% of that, and then this very over-engineered app provides you another 50% of it. And so you really have to dig through and figure out what's all there. In the end, I decided that was all very complicated, and I'm just going to write the 100 lines of code it takes to put a camera preview on the screen and click a button. But I applaud Apple for putting a UI there. At the same time, I'm like, the UI is obviously only 50% done because the sample app is way too huge. The sample app should be like 4 lines of code. Here's how to bring up the UI.
Yeah.
The end. That's it.
Yeah.
There's your...
I mean, that's the problem, right? Like, we often talk about this. Like, what are we teaching the person in this sample, in this module, in this documentation? Are we, we start with that all the time. Like, even when I do the workshop, like, okay, it's like, am I teaching people data binding right now? Am I teaching them like a list? Like, am I teaching them this thing? Or am I teaching them Azure? Or am I just teaching them feature flags, right? Like, it's so easy to conflate multiple kind of subjects together because they're complementary in a way. It's like, oh, of course, like, why wouldn't you want to like have this thing and then do that thing, and like, this is how you would do it. But then really it's like, you just want to get a bunch of photos and then shove it in here, right?
Can I just complain for a minute? I like to complain. You let me complain.
Oh gosh.
UIKit APIs used to be so simple. There'd be an object that did something, and then maybe you attach a delegate to it, and it would send you events when it's doing something. Lickety split, no problem. This is the same kind of problem. They have a little photogrammetry object, and it needs to send you events. But James, it sends you events in the most ridiculous possible way imaginable. There's one channel for like control events, another channel for data events. In the sample app, they wrap up the data event async queue thing into their own infinitely looping async function, which signals an async actor, which then launches a message on the global message queue, because in the end, that's all you really want to happen anyway. And I just find it like crazy, this API that like in the old days is so simple. Like in the .NET version of that would be, it's an object with a bunch of little event guys on it. The Objective-C way is a delegate object. The Swift way is 3 different concurrency abstractions all signaling into the UI, and it's a little bit mind-blowing. The good news is look at their example and say that's a nice UI, and then throw it out and start over from the raw API, because the raw API isn't as bad as they make it look.
So you obviously did that, and now you're scanning your shoe again. And now let's get back to Mo. We sidetracked a little bit in good spirits though, to scanning the underside of the shoe, because if you remember, if I remember the shoe, I don't remember how. What would you say the percentage of the shoe that you got with the Mac app before? Was it like 80% of the shoe, 90% of the shoe, 100% of the shoe? I forget. Did you get the underside of the shoe?
If we're talking surface area, it's probably less than all that. Probably like 60%. I only took like 15 photos, and I took them very poorly because I had no idea what I was doing in the beginning. It was my first real experience with photogrammetry. So I missed important things that you learn. Like I missed the inside of the shoe. Turns out shoes have a place where a foot goes, and it's deep and dark in there, and you need lots of light. Part of Apple's thing is it just that their built-in UI is it sends you events whenever it wants to warn the user of something. And the event they love to send you is more light. We need more light. You just flood the room with light if you're 3D scanning an object.
Well, because ideally, if you're 3D scanning an object, like this would be almost like a photo shoot. You know, when you see like a family photo shoot or a dog photo shoot, they have that big like white screen behind them. It's like sitting on it's like all nice. Like that's the type of stuff you want to get rid of, all of the extra things inside of it. And it needs to almost be dangling in 3D space in some way. And then there's lights just flooding into the room to make this happen. That's what ideally you should do. But I'm assuming you don't have that set up at home, Frank Krueger.
Oh no, I just took pictures on the carpet that has a little stain on it a little bit right there. So, it's fine. Actually, I think they recommend like a medium gray. So like the photo thing, but not all white. You want a medium gray, and you just want enough light sources, enough bounces, enough diffusers where you have minimal shadows. Shadows are your enemy when 3D scanning. Reflections are your enemy, mirrors are your enemy, and shadows are your enemy. But other than that, you can just throw it on the floor, stains and all. Their algorithm is really good at finding a horizontal plane. It wants a horizontal plane, so you can't 3D scan things on a wall, even though you totally can. Their algorithm's powerful enough. I've gotten away with it. So things just like hanging on a hook on the wall, as long as it can see a floor to kind of get its bearings a little bit at first, you can start scanning other objects right away. Once you have all of that, totally forgot what we're talking about now, James. What do we want to do after we've gotten it level? We want to walk around it. You want to walk 360 degrees. You can't do that. You're going to walk 180 degrees, get the whole hemisphere, and then do the best possible mode ever, which is engage flip mode. Finally, you can flip the object.
It's like you have to tell it that as like a Boolean, basically. Wow.
Yeah, you have to signal to the API, I have instructed the user to flip the object. Wow. And then the user has to confirm it's a dead man switch. No, I'm just kidding. And then you have to make sure that they, you don't want to re-engage the camera until the user has done flipping the objects. You don't want that transitional flip. You just want a nice concrete flip. And the reason you have to do that is when you're doing that first pass, it has to align all those cameras. It has to figure out each photograph. It has to figure out what was the orientation and position of the camera for each one of those photographs. And it does that by playing a little optimization game, looking for similar patches on the object, a little red dot. It would focus in on that red dot, try to find that red dot on all the pictures, run an optimization algorithm to figure out the positions of all the cameras. But if you flip an object, you just ruined all of that. All that optimization algorithm is out the door. So it's a nice, it's basic. It is, it's obviously a required feature, but it's funny how many photogrammetry things don't do this. So when you say I'm flipping the object, what you're just signaling to it is treat that first group of cameras or photographs as one set of orientations for the object, treat the others as another. It actually has to run 2 passes and then intelligently optimize all of them together and try to paste together the object from that. So it's a clever algorithm because it does distinguish the object from the background, from the floor, from the plants, from the other things. It's not being simple. It's being very a little aggressively complicated, actually, sometimes. But that's what allows it to, after you flipped it, took a new set of photos, it's able to integrate them all together.
Nice. And then you run it through the algorithm and it gives you mesh back? Or like, is there a way for it to know like the percentage of accuracy? Like, because, like let's say I'm doing a 3D sphere image or whatever. It's like, hey, you're missing this thing. I'm assuming it's just going to do its best educated guess with whatever you gave it. It doesn't know anything. It's not, it can't be like, oh, we think that this is 80% complete. Please take a photo of this. I'm assuming that's not the case.
Well, actually, a lot of that is built into the UI that they have.
No.
/ over-engineered sample app. So they have a cute little animation of like, when you do like Face ID thing and it does like the circular progress bar? Yeah. It does that. Yeah.
Oh, interesting.
So that's baked in now.
Do you think that this technology is the same as the 3D, like as the Face ID, because it's doing a 3D mesh? No, okay.
I wish. Okay, with caveats. It is not using the depth sensor. So this can all work with just photography. So that's the fancy, what's called the structure from motion, SFM algorithm. With no depth information, just comparing images, it's able to figure out 3D information.
Wouldn't it be better with the depth information or no? Or does it not matter?
Certainly, sir. In fact, you can feed it the depth information, but all it uses it for is to scale the world. So it just, if you think of it just going from pictures, there's ways to orient and make cameras make any object look any size or any size. You know what I'm saying? You can. Yeah. The size is relative in a photograph. So to give it an absolute size, you can feed it depth information. It can integrate that to scale things. But no, it doesn't actually use it for generating the mesh. That said, I'm working on an app that does. So the big problem there is that the depth map is often lower resolution than the image. And so you can actually get higher quality data if you take a billion million little images. No one ever wants to take enough images. We all take like 10 and we're like, that should be enough. But really, you want to take like 30 or 40. And then the algorithm can do a really good job at pulling things out.
Gotcha. Nice. So then with these mesh files inside of RealityKit, you can just render them and display them easily enough then? Or like, how does that work?
Actually, I should enumerate what you can get from it. So, and I wanted to go back to, you were talking about, does it give you error information? No, it's Apple. It's Apple. No, it gives you nothing. Nothing. It's frustrating how little the API gives you. All they want to do is plop this mesh into your hands. That's what they want to do. I want more information. So, although the API is at least 2 years old, they finally added one more bit of information that you can get out of it. So the things you were able to select in the past were the boundaries of the object. Yay, boring, but there could be simple scenarios where you're just trying to roughly measure something. You can get a point cloud where you just all the points it used to figure out the 3D information in the scene will come back as 3D points with colors. And honestly, that's just a quick and cheap way to render it. And point clouds are often just fine. Honestly, people get used to them. They kind of look like holograms, in my opinion. I think they're kind of fun and interesting. Then the mesh can come in two flavors. The one that they used to support, the original, was it just wrote it to disk. And it would write it to disk in USD, Universal Scene Description format. It's a Pixar format. Talk about over-engineered. It's a super over-engineered file format, but USDZ is Apple's preferred format on iOS for the last few years, and on visionOS for sure, for shipping around different meshes. They want you using USDZ. The Z is just a zip file. It's a USD file. A USD file can come in a binary format or an ASCII format. Again, all super over-engineered, all complicated. Nice. And then lastly, you can just get the mesh back as an in-memory RealityKit object, and you can just plop it into your visionOS world, and bloom. Now you have a virtual object of your once physical object. You may now destroy the physical object. It is useless because you have the physical or the virtual version of it now.
You know, if they do enable it on visionOS, which you think that they're going to, do you think it'll be possible then to like walk around? There's external cameras, obviously. Do you think they'll enable it so you could just like use the Vision Pro headset to be like, oh, here's a can, I'm holding up a can, and I'm just like with my headset, right?
That's why I was so excited that I saw that all this was supported according to the docs in visionOS. I was literally going to write that app. Apple should release it, but Apple doesn't have a great track record in releasing apps they should release.
Yeah.
So I was going to just have a day one app to do it, but so far I haven't gotten it to build. But you're absolutely right. The thing is covered in cameras to do a fantastic job. Maybe rotating in your hand would be one way to do it. It'd be nice if you could like clip out your hand or something. But
yeah, like if you could do that, then you could almost build like The Sims, right? It's like my house. Like, I'm gonna here's the things, and like, oh, now this thing's over here. Now like here's my setup. And now what would be really cool, right? Is like you have your desk setup, and then you could have like virtual things that are like important or whatever, and then you can use some stuff. I don't know, it'd be kind of cute.
Or just silly things like if you're about to redecorate your living room, like go do a quick scan of your living room so that you have like a before and after. I was thinking like when I throw out an object or get rid of something that I've had for a long time, I'm probably just going to do a quick 3D scan of it. A friend once told me, like, if you have an object that you're attached to but you still want to get rid of, just take a picture of it. At least you have the picture. Well, now I'll do a 3D scan of it and have a little 3D object.
Oh, why do you think that my OneDrive is 98% full all the time? Because I'm always storing as many things as humanly possible. It's like, take a photo of this, take a video of that. Just I don't want, in case I delete that file locally, might as well upload a copy. What's on that USB thumb drive? I don't know. Now it's on OneDrive. Like literally, like I have like, I think, because you have a bunch of like SD cards and thumb drives just sitting around. You don't know what's on them. You don't know if you need them after you plug them in. You're like, these files... I don't know what this is. Boot disk? Probably.
Yeah, it's a Linux install from 4 years ago is usually what mine is.
Mine's like, I'm like, okay, zip it up, put it on the cloud. Like, I don't know. And then it's just like, and I'll be like, thumb drive found on March 23rd, 2020. And you're like, okay, cool. Like, great. Nailed it. So, yeah.
So I'm really curious to see what happens. There's already a lot of 3D scanning apps on the App Store. They all just found some open source library, shoved it into an iOS app, got it on there. Or the terrible ones make you upload all your data to a server, and then they just run it on the server. Only a few of them, I think, will actually run on device. So now there's a pretty easy way, definitely a big example. You can just go copy and paste and rebrand it to yourself and say, hey, look, I have a 3D scanning app now. So I'm curious if there's going to be a bunch of those, or if people aren't going to bother because, like I said, the market's already pretty saturated. But then you have weirdos like me who still think I have a few games to play. I have a few little tricks up my sleeve that will introduce some new things that the other ones aren't doing. So I'm still going to give a try at it. I'm curious if I'm entering a space that's going to be flooded with copies of the Apple Sample app, if uh, or if there'll be like visionOS ones. I would hope there'd be visionOS ones. Anyway, now that it's a simple API, it's baked into the OS. I'm just curious to see if it gets any traction, and I really hope it does because I would love a crazy 3D scanning future.
Yeah, I think I'm going to go download that sample. Just send me a link to it, and we'll put it in the show notes, and definitely get that up and running in Xcode. That's for sure, and get it on my phone because I feel like that'd be a fun sample to see where it's like this sample is a fully fledged app, right? You know, it's like, oh, cool, thanks. We documented one API with 85 hours of engineering. Thanks, Apple.
Perfect. It took me 15 minutes to like find the API that like sent me to that app.
Nailed it.
I got lost in Swift abstractions.
Classic. Oh my goodness. All right. Well, I'm gonna go give it a try. That's for sure. Let us know what you think. Are you going to be building 3D cool things? Do you want to be scanning 3D things? Right into the show. mergeconflict.fm. There's a contact button. You can hit us up on. I don't know what the name of the social media platform we use is anymore. Is it Twitter X?
Are we off Threads already?
Twitter?
Yeah.
Twitter X.
I try to ignore all branding, so I'm just going to call it the Twitter.
You can search Twitter, and then you can tweet, but then it's very strange. Am I still on Threads? No, I'm not still on Threads. I'm still have an account on Threads, and I'm not a big social media person, and I mostly just Instagram. That's pretty much it. So, yeah. And then not even really that much. I don't even post anything. I just like browse cute dog photos. So I think that's what the internet is for, right? Just joyous animal photos.
Not everyone needs to contribute. We just need a few cats a day. It's enough for the entire world to get by on.
Exactly. Well, hit us up on the Twitters at mergeconflict.fm or James Montemagno or Proclaim. We're somewhere on some social media account somewhere. That's going to do for this week's podcast. If you have ideas, we're coming up on 3. What are we coming up on? We're coming up on
7,000.
No, we're coming up on
close.
Oh yeah, 370, which will be next week. If you have questions that you want us answer, that's a lightning topic, right into the show. Tweet at us, do anything. Give us your topic. 5-minute topics. We'll be covering them next week. But until then, I'm James Montemagno.
And I'm Frank Kruger. Thanks for watching and listening.
Peace.